Welcome back. Continuing our study of logarithms, we're going to talk about common logarithms and change of base today. Let's talk about common logarithms. If I see log x, it really means log base 10 of x. Our calculator, when we hit that log button, is a base 10 understood. So it's kind of like if I saw a and I said, how many a's are there? We would say 1, as we know there's a 1 in front and it's to the first power. We know they're there, we just don't write them. So logarithms, when I see log x, we know it's log base 10. If it's anything other than a base 10, then we have to write the log there. Because our calculator button, that is log, is base 10, that means we don't have to do anything fancy. If I want to know the log of 1000, I can just hit log 1000 in my calculator. And when I get an answer, it'll be 3. The log of 142. If I type that into my calculator, round it to the hundredths place, I get 2.15. Log, again, this is a base 10 because it's not written, so I can just hit the log button in my calculator. Parenthesis pops up, we close it after that, and we get negative 2.23. So for any number where we have a log that's greater than 1, then our answers are always positive. If we take the log of a number between 0 and 1, then the answers will be negative. Now, what happens if we try to take the log of a negative? We talked about if our number is greater than 1. We talked about if our number is between 0 and 1. But what if we have a negative number? What if I want to know the log of negative 16? Well, when I type that into my calculator, I get error, non-real answer. What if I want to know the log of negative 0.002? Well, when I type that in, I get error again, non-real answer. Remember, we're asking the calculator, for example, in this, that's log base 10 and negative 16. 10 to what power is negative 16? Well, I can replace x with any positive number, and I just get big numbers. They keep adding zeros. I can put 10 to the 0 power, and I would get 1. I could put 10 to any negative power, and all that's doing is taking the 10 and flipping it under 1 and making it a super small number. I will never be able to get 10 to some exponent where I get a negative answer. It'll never happen. And so that's why they're telling us that the log of a negative number is never going to happen. It's always going to be an imaginary answer. We're not going to talk about those this go around, but we just need to make sure that we're aware of that. So what are some uses for a logarithm? Well, if we talk about the chemistry of some kind of a solution, if you have a pool or a hot tub at your house, I'm sure you've talked about the pH of that. So you have to be very careful of the balance of the pH in our pool to make sure it doesn't irritate our skin or our eyes. And so we have this formula here, negative log of the hydronium. And the base here, because they didn't write anything else, is a base 10. They're asking us in this first example to replace this H3O plus or hydronium ions to 2.5 times 10 to the negative fourth. In my calculator then, I'll hit the negative button, the log button, and then 2.5 times 10 to the negative fourth power. And when I hit enter, I will get roughly about 3.6 for our pH. For the second example, now they're telling us that the pH is 7.1. So we're plugging that in for pH, and we have to find the hydronium ion. So if I write that as an equation, we would have 7.1 is negative log, and I'm going to put that as X rather than H3O plus, just to make it a little bit easier to see. Remember, this is a base 10. Before I can do anything with the log, I have to get rid of the negative in front of it. That's a negative 1 times log x. The opposite is to divide by negative 1 on both sides. That makes that a positive log base 10x and a negative 7.1. Well, I can't type log in the calculator of x because I don't know what x is. So let's rewrite this in exponential form. 10 is our base to the negative 7.1 power is equal to x. Remember, I could write the negative 7.1 on this side so it's left, right, center, if that helps. And I just typed 10 to the negative 7.1 in my calculator. When we do that, we have 7.98 and a bunch of numbers, and then e to the negative 8. That e is short for times 10. And that means that our answer to that would be 7.98 times 10 to the negative 8th power for the hydronium. Another way that we can use logs is if we're talking about the loudness of sound in decibels. We have 10 times log, and again, this is a base 10 because I have nothing else written there, of the intensity over the initial intensity. So the intensity here, or I, is going to be 10,000 times the initial intensity. D equals 10 times the log of 10,000 initial intensity over initial intensity. Remember, that's a fraction, so our isobos reduce out, and I'm actually just doing 10 times log 10,000 in my calculator, and when I do that, I get 40 decibels. If I do the same thing over here with this next one, we have 10 times the log of 10 million times the initial intensity over the initial intensity. Reduce that out means in my calculator I'm typing 10 times log of 10 million, and we get a decibel of 70. ln. ln is natural log. They put the, natural log. They put the N and the L backwards from what we actually say, the natural log of x. They write it as log natural of x, which represents the power that base E must be raised to in order to understand x. So our ln button, which is just underneath the log button, if I see this, it really is base E. Again, they just don't have to write it because it's understood. So when we type this in our calculator, natural log of e to the third, we get 3. If I hit the ln button, 142, I get 4.96. And then natural log of that decimal, we get negative 5.14. Remember, this is raising e to the roughly 4.96 power to get 142, and e to the 0.005832 power. I wrote that backwards. E to the negative 5.14 power to get 0.005832. So we're raising base E rather than base 10. Well, that's great, but what happens if I don't have a base 10? How do I get that in the calculator? What if my calculator doesn't have the log base button? Well, that's okay because we can use the change of base theorem. And basically what that says is we take our log 17 and whatever our base is stays on the bottom, and we divide by log 5. Vitally important, when you hit the log button, a parenthesis comes up. So you have to make sure that you close it after your top number before you hit divide by the log of the bottom. If you don't do that, then your calculator is finding a different log. If you've typed this in correctly, you should get 1.76. Example B would be log 0.1 divided by log 2. It doesn't matter that 0.1 is less than 2. What matters is 2 is our base. And so that lower number always stays in the bottom of our fraction no matter what. And we would get negative 3.32. This would be log 20 divided by log 4, which we would get 2.16. Log 0.7 divided by log 2 be negative 0.51. Would make sure that change of base formula gets noted for your note card on your test. Thanks so much for joining me. Have a great night.